Today we want to see how we can solve these critical questions on the board. This type of questions, when it comes to exam, students normally run away. But today we want to break it down to the understanding of the student. Let's see how we can do it. Now, from the question, we have been told that a boy has to cover 4 kilometers to catch a bus. So from the question, the total distance is given to us. So we write total distance. All right, so we put our data down. Total distance is 4 kilometers. Nicely. Then we proceed. He walks part of the distance at 3 kilometers per hour. Now, 3 kilometers per hour is a unit for measuring speed. So that will be the walking speed. So we have walking speed, which is given to us, which is 3 kilometers per hour. All right. Again, we have been told that he runs the rest at 5 kilometers per hour. So which means running speed is also given to us, all right, at 5 kilometers per hour. And the total time is given. He takes 1 hour to complete the whole distance, all right. So we have total time, which is given to us as 1 hour. All right, let's see what we are looking for. For how many kilometers does he walk? So we are looking for walking distance. We don't know, so we can use a variable to represent it. So we can say let x equal to walking, all right, walking distance. Now again, we need to solve it with relation to running distance. So we can say let y also represent running distance, all right, as we can see. Okay, with this data we have, let's see how we can analyze the question. Now, since we have the total distance given, we can mathematically say that our walking distance plus running distance should be equal to the total distance given. Then we can name it equation 1. Now, what again? We have been given the total time. So what can we do? We need to find the time for what? Walking, and time for what? Running, so that we can also equate it to this. Now, we know that speed mathematically is equal to distance over time, all right? Distance over time. Therefore, time will be equal to distance over speed, as we can see here. Nice. Therefore, let us find time for what? Walking. All right. So time for walking, let me use TW to represent it, will be equal to distance for what? For walking, which will be x, divided by speed, which will be 3. So we have this as we can see here. Again, let us find time for running, okay, which will be distance over speed, and the distance is y, and the speed for running is 5, all right, as we can see here. So mathematically, we can say that time for walking plus time for running should be equal to the total time that we have here, all right. So we know time for walking to be x over 3, time for running to be y over 5 should be equal to 1. All right, we can name this equation 2. Now, since we are looking for, that is the distance used in walking, which is x, it means we don't need y. So we can easily make y the subject in equation 1. And we are going to have 4 minus what? X, as we can see here. So what do we do next? We fix this into equation 2. So we are going to arrive at x over 3, right? Plus, now anywhere we see y, we put this there. So 4 minus x all over 5 equal to 1. Mathematically, what can we do? We find LCM, which will be 15. So we use our 15 to multiply each of the 10. So we have x over 3, 15 here multiplying 4 minus x all over 5, and 15 multiplying 1, as we can see. This will nullify this. We have 5. 5 multiply x. We have 5x. Alright? Plus, this will go here, 3. 3 will multiply this. We can show it as this. And 15 times 1 will be 15. So here we simplify this. 12 minus 3x equal to 15, as we can see. So we break it down as 2x, 15 minus 12. So 2x equal to 3. Divide here by 2, here by 2. So x will be 1.5 kilometers. So our walking distance in kilometers is going to be 1.5 kilometers. Now, try question number 2 and put your answer in the comment section. But don't forget, here our time is in minutes, so you change it to what? Hours, so that it can work with the kilometers and the speed given. Thank you.